So today we're going to cover Chapter 10, Section 5, and we're going to see some angle relationships in circles. So the first slide is a theorem, and it's called the tangent and intersected chord theorem. And this one states that if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So in this particular picture, angle 1 is in red, and its intercepted arc goes from point A all the way around here to point B. So let's say I told you that the measure of arc AB was 110. In order to find angle 1, what I need to do is take half of AB, which was 110, and the measure of angle 1 is going to be 55 degrees. Now, in order to find arc BCA, if you recall that a complete circle has 360 degrees, if I needed to find this arc measure, all I would need to do is take 360, subtract the AB arc, 110, and then what's left for arc BCA would be 250 degrees. So that would be this arc. And if I wanted to find the measure of angle 2, I could just do angle 2 is equal to 1/2 of the measure of BCA, which was 250, and angle 2 is equal to 125 degrees. Now, technically, I really didn't need to go through all of that just to find angle 2 if that's all they were asking me to find. Because if you remember back from the beginning of the year, whenever you have a straight angle and two angles are sitting on that straight angle, these are going to be supplements. They're a linear pair. So really, to find angle 2, all I really would have needed to do was take angle 1, subtract it from 180, and I could have gotten angle 2 to be equal to 125 that way as well. So in some of these problems, there's more than one way to go about finding all of the missing pieces. Next theorem is called angles inside the circle theorem. And this one states that if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So in this particular picture, angle 1 is here, its vertical angle is over here. So to find the measure of angle 1, I would be adding its intercepted arc, the CD here or the DC, along with its vertical angle's intercepted arc, and then times it by 1/2 or divide by 2. Now, to me, these angles that are inside here that are formed by these intersecting chords, they sort of look like they're floating inside the circle. So I refer to this theorem as the floating angles theorem because it looks like they're floating inside. Now, this vertex here, it's not the center. So these angles are not central angles. If they were central angles, then the arc measure would be equal to the central angle measure. But these are floating inside, and that vertex is just somewhere in the circle. It's not the center. Now, another way to find angle 2, if I didn't want to add arc BC and add arc AD and divide by 2, another way to find angle 2, if I knew angle 1, remember angle 1 and angle 2 together, these are supplements. They're a linear pair. So another way to find, once I find one of them, all I would need to do is subtract 180 from it. So let's add some numbers to this. Let's say I wanted to find the measure of angle 1. And let's say I was told that this arc measure was 80. So DC is 80. And let's say I also gave you that AB was 40. And they said, find the measure of angle 1. So in order to find the measure of angle 1, I'm going to take DC, which is 80. I'm going to add that to AB. And then you can either multiply it by 1/2, or what I like to do is divide by 2. So this gives me 120, divide by 2, and angle 1 equals 60 degrees. Now again, if I wanted to find 2, I could either just do 180 minus 60, and angle 2 is going to be 120 degrees. Let's say instead of doing it that way, let's say they had given me that this arc measure AD was 120. Then if I wanted to find angle 2, I would first need to find BC. And BC, notice I've got 40, 120, and 80. To find BC, I could add 40, 120, and the 80. And then this is going to give me the total, which would be 240. Subtract that from the whole circle. And then BC, coincidentally enough, would also be 120. It's not always going to be congruent. So in this case, if I wanted to find angle 2, I would have added the 120 from AD and then add that to the 120 from BC, divide it by 2, 240 divide by 2, and I could still get angle 2 equals 120. Same answer I got when I just subtracted it from 180. So again, multiple ways to do these. Next is called angles outside the circle theorem, and we have 3 different scenarios for this theorem. We either have a secant and a tangent, 2 tangents, or 2 secants. These will form an angle outside of the circle. Then to find the measure of the angle, we're going to take half of the difference of the measures of the intercepted arcs. Now I'm going to simplify this a little bit. So this first picture, this is a picture of 2 secants. And they're forming outside angle number 1. Then the second picture, these are 2 tangents that are forming angle 1. And then the last picture, this is a picture of a secant and a tangent. And they're forming angle 1. So in order to find the measure of this outside angle, what I like to do, instead of referring to these arc measures as X and Y, I'm going to refer to this X over here as being big arc, it's the bigger piece, and it's furthest from the angle. So this is my big arc. And on all of these where I see the X, this is big, and this is big arc. And then the little arc is going to be the piece of the arc or the circle that's closest to the angle. So I'm highlighting that in blue, and that's where the Y is. So this is all going to be my little arc here. So this one's little, and so it is here. So those are little arc. So the formula I'm going to do is, instead of memorizing this, which you can as well, is the outside angle, and in this case, it's angle 1, is going to equal 1/2 of the big arc minus the little arc. Or you could also do big minus little, big arc minus little arc, and then divide it by 2. So either way, and that's going to give you, in this case, the measure of angle 1. All 3 scenarios, it's still the same formula. So big arc minus little arc times 1/2, or big arc minus little arc divide by 2. The next slide is the definition of a circumscribed angle. And a circumscribed angle is an angle whose sides are tangents to a circle. So my circumscribed angle is this angle right here, ABC. So the circumscribed angle is angle ABC, or you could name it in reverse. You could call it CBA. That's the circumscribed angle. And notice the sides that form that angle, they're tangents. So AB is a tangent, and so is BC. So the sides that form the circumscribed angle are going to be tangents. All right, next is the circumscribed angle theorem. And this is going to tell us how to calculate the measure of that circumscribed angle. So in this picture, my circumscribed angle is this angle ADB. So this is the circumscribed angle. And the measure of the circumscribed angle is going to be equal to 180 minus the measure of the central angle, and in this case, it's the ACB, that intercepts the same arc. So the arc that the circumscribed angle has is this arc AB. It is the same arc for the central angle ACB. So you're going to find the measure of the circumscribed angle by subtracting 180 minus the central angle measure. So here is where we need the prior knowledge from the beginning of the chapter of how to identify a central angle. All right, everybody good? Let's go on. So let's do some examples. So in this picture, they're giving us that UT is a tangent, and also what they didn't tell us, but we can tell from the picture, that US is a secant. So US is a secant. Notice this 30-degree angle here. This is an outside angle that's formed by a tangent and a secant. So what I'm going to do first to find the measurement of arc WT, WT is right here. And notice this is going to be my little arc. And the big arc that is intercepted by these two, the secant and this tangent, the big arc is located over here, from over here to S to T. So this is big arc over here. So to find little arc, and I'm going to call this X, which is going to be my WT, I'm going to be doing the formula outside angle, and in this case, my outside angle is going to be this 30, is equal to big arc minus little arc divide by 2. So let me fill in my numbers. So my outside angle is 30 degrees. My big arc is 100. I don't know little arc. And then the divide by 2 is part of the formula. So again, remember X is arc WT. So I'm going to go ahead and solve this. So what I need to do here is multiply both sides by 2 to cancel the fraction. And then I get 60 is equal to 100 minus X. Subtract 100. And I get negative 40 equals negative X. I can't have a negative variable, so divide both sides by negative 1, and X equals positive 40. So my little arc, which was WT, is 40 degrees. So that's the answer to part A. So this is 40 here now. So part B, they're asking us to find angle TVS. So TVS is right here, this angle measure right here. Notice what I can use for this one is my floating angles. So I'm going to take its intercepted arc plus the intercepted arc of its vertical angle. I'm going to add them and divide by 2. So for part B, this is that floating angles theorem, or angles inside the circle theorem. But again, I call this floating angles. So I'm going to be taking angle TVS is equal to 100 plus 110 divide by 2. And TVS is equal to 210 divide by 2. TVS equals 105 degrees. So this angle that's right here is 105. Now the next piece that they want me to find is the measure of angle RVS. And RVS is located right here. The easiest way to do this is recognize that this angle and this angle are sitting on a straight line. It's a straight angle, it's a linear pair. So for part C, the easiest thing I can do is just take 180, subtract 105, and angle RVS is going to be 75 degrees. And then the last one, it's asking me to find the measure of arc RS. So RS is right here. So if you think about it, probably the easiest way, we could do our floating angles. However, the easiest way to do it is if you notice, we already have every single arc piece except for that one. So I'm going to do and just take the 110, the 40, the 100. I'm going to add those 3 arcs and then subtract from 360 to get the measurement of arc RS. So 360 minus 250 and arc RS is equal to 110 degrees. We could have also done our floating angles, but again, multiple ways to do these. So for example 2, it wants me to find the measurement of arc AB, and arc AB is right here. Actually, let's do this in blue. So this angle D is my outside angle. So it's right here. So what I'm going to be doing here is my outside angle is equal to big arc minus little arc divide by 2. So little arc is in blue. Big arc will be in red. So this will be big. This will be little. And then angle D is the outside angle. So I'm going to be doing big arc minus little arc. And I'm going to divide it by 2. So let's go ahead and fill in what we have. So they're giving us the measurement of arc AB, and that's 105. Now, the only time that we can find the other piece of the arc is when we have 2 tangents. So if you already noticed that little arc is part of the circle, and then the other part of the outside edge of the circle is the big arc. in order to find big arc, all I have to do is 360 minus 105, and big arc is 255. This only works when it's two tangents. So this is 255. Now I can plug in these two numbers to get angle D. So angle D is going to be big arc, 255, minus little arc, which is 105, and then divide by 2. So angle D is equal to 150, 255 minus 105, divide by 2, and angle D equals 75 degrees. So for example 3, this time they want me to find the measurement of arc AB. And arc AB, this is big arc. So this is big arc. The 20 is my little arc. So this will be little. And then the 10 is my outside angle. So I'm using the same formula again because this is 2 secants. So 2 secants, I'm still doing the same formula. Outside angle is equal to big arc minus little arc divide by 2. So let's fill in our numbers. We know the outside angle, it's 10 degrees. My big arc is what I'm looking for. So I'm going to call this X. So I don't know little arc, it's 20. And then again, the formula is times by a half or divide by 2. So again, I need to solve for X. So I need to get rid of the fraction. So I'm going to multiply both sides by 2. And now I'm left with 2 times 10 is 20 is equal to X minus 20. Isolate X by adding 20. And 40 is equal to X. Remember, X was my big arc, which was arc AB, which is what they had asked me to find. So arc AB will be 40 degrees. So the last example wants me to find the value of X. So X, in this case, is going to be my circumscribed angle. It's formed by 2 tangents. So this is a circumscribed angle. So what I can do here is I'm going to be using the formula. I'm going to use my circumscribed angle theorem. And I know that the measurement of this circumscribed angle, ADB, so the measure of angle ADB is going to equal 180 minus the measure of the central angle that has the same intercepted arc as my circumscribed angle. So I'm going to subtract out the measure of ACB. So the measure of angle ADB will equal 180 minus 135. So the measure of angle ADB, which in this case is X, is going to be 45 degrees. Using my circumscribed angle theorem. Okay, so this is just a little review of all the angles we've talked about so far. So the first type of angle we talked about was a central angle. So a central angle, remember, is formed by 2 radii. So this could be ABC. AB is a radius, and so is BC. So angle ABC here, or we could also call it CBA, this is an example of a central angle. And when it's a central angle, the vertex of that angle is at the center. So it's at the center of the circle. Remember that the measure of the central angle, this ABC, is going to equal its arc measure. So angle ABC is going to be equal to arc AC. So if I told you arc AC was going to be 60 degrees, then so would angle ABC. So they are both going to have the same measure when it's a central angle. The next type of angle we talked about was an inscribed angle. So when we have an inscribed angle, this is when the vertex is sitting on the side of the circle. It's formed by two chords. This is an inscribed angle. And again, I can call it ABC. Remember, the measurement of an inscribed angle is going to be half of its intercepted arc. So here, if the intercepted arc here is 60, then angle ABC would be 30. So this would be 30, and this would be half of 60, which would give us the angle measure. So this is when the vertex is on the side of the circle. And then the third one that we've already talked about is when you have a tangent and a radius. So if I have a radius and a tangent, let's call this A, B, C. So this will be a tangent and a radius. When they intersect, their intersection will form perpendicular segments or perpendicular lines. So in this case, you could say that AB is perpendicular to BC. And it could be line BC, but this would be a segment. And when you have perpendicular lines, then we know that angle ABC is going to equal 90 degrees. So it's going to form a right angle when you have perpendicular lines. So this was something that's already been covered. It was on the test. Next, we're going to cover the new information that we just talked about today. So next, I'm going to talk about a tangent and a chord now. So when we have our circle, and let's say we have a chord intersecting a tangent. So this is a tangent and a chord. Here, if I put an angle 1 here, the measure of the angle that's formed by the tangent and the chord will always be half of its intercepted arc. So if I told you here that the arc measure was 100, then in order to find angle 1, I would find half of 100, and angle 1 would be 50 degrees. Then we also had the floating angles. Draw a picture of that. Floating angles are formed by two chords. Again, remember these angles are not central angles. So if I put A, B, C, D here, so I told you this one's 40 and this one's 60. So again, these are angles inside a circle. Again, I call them floating angles. It's not an official name, but that's what it looks like to me. So here, what you would do to find the measure of angle 1, you're going to add arc AB plus arc CD and divide it by 2, or 1/2 of that. So angle 1 would be 60 plus 40, divide by 2. This would give you 100, divide by 2, and angle 1 would be 50. All right, last scenario. And I'm going to draw 3 circles here. Here's my first one. Oops. Next one. And lastly, one more set. So here, the first one will be 2 secants. The purple one could be a secant and a tangent. And then the last one will be 2 tangents. Oops, let me do it in blue. All of these have an exterior angle 1. And all 3 have the same formula. So we can say that angle 1 is going to be equal to, and let me go ahead and big arc on all of these, minus little arc, which will be right here. So it'll be big arc minus little arc, and then divide by 2. So again, all the blues are little, and then all the reds are the big arcs. So blue is little, red is big. Then the other one that we also covered was the circumscribed angle. And the last one is the circumscribed angle. And this sort of looks like the outside angle of the tangent, but just remember you're going to also have a central angle here. So this angle 1 could be your circumscribed angle. And that's going to equal 180 minus the central angle. So let me add some letters here. A, B, C, D. So this could be angle D is going to be equal to 180 minus angle ABC. It's the same angle that has the same intercepted arc. So we're looking for this central angle because it has the same intercepted arc as your circumscribed angle. So this is a nice little summary of everything that we have talked about up until this point.